Hey guys, today I'm going to be sharing with you my very own Telegram-based YouTube assistant agent that I've been working on to build for the past week. And honestly, I'm really pleasantly surprised by how well it works. But it took me more than 40 hours to build this with many trials and errors, trying to figure out the right prompts and the right structure for this use case. But I eventually got it to work, and I'm just really stoked right now to show you guys what this agent is able to do. So without further ado, let's just get started. By the way, I'm going to be uploading this template to my Skool community, which is currently free until we hit 50 people. So definitely join now if you want to enter for free. With that said, let's get started. So I want to first start by demonstrating to you some examples of what this agent is able to do so you can see it in action. And then we're going to be going through the workflows step by step and see how this whole thing works. But yeah, for this, I'm just going to go to Telegram and I'm going to start with what can I use you for? All right, so it returned a list of things it's able to do. And I'm just going to go start with generating timestamps. For this, I'm going to go to my video, my only video. And let me explain why I actually decided to implement this feature. The reason was because when I was preparing the timestamps for my first video, what I noticed was it was taking me a really long time to actually just prepare it, right? For instance, it took me around 25 minutes because I had to go over the video manually to figure out at which exact moment the sections began. So it was just really tedious and kind of annoying. So then it occurred to me, like, why don't I just like try to delegate this to AI? But I was not sure if it was going to work. However, I was actually pleasantly surprised with how well it works. And honestly, I'm just really happy that I tried. I'm just going to show an example to you guys right now. I'm going to copy paste this link here and say, please generate the timestamps for this video. All right, now you can see that it says processing your request. Please wait. What's happening here is it's an intermediary tool that it uses to send a message before actually calling the tool to generate these timestamps. And let's just now wait until it actually generates it. All right, so we got it to generate the timestamps for us in just a minute, or actually even under a minute. And honestly, guys, again, like I said, I'm again mind blown by how consistent and how accurate it's able to consistently generate these timestamps. This is exactly what the content is about in the video, because I've tested it out so many times that I already know the exact map of the video at this point. But just to show you guys, I'm gonna try, like, for instance, let's go to video overview, right? 2 key sections. I'm gonna go here and click on the time given. You can see that we are talking about 2 sections here, and it was able to successfully generate a timestamp for that. And if we looked at some other parts, for instance, the memory component here, 426, let's look at that. Let's go to 426. Again, here we are at the memory component exactly when we start talking about it, right? And it was accurate with that. For instance, let's go ahead and look for another thing, like in this part, Google Calendar tool. All right, so now we're at 2047. Let's wait for 2051. So for that, let's actually connect to the Google Calendar tool. And to do that, we'll click on this plus sign under tool this time. Okay, guys, you can see that this was too accurate. And let's actually, to check the consistency of the timestamp generation, I'm going to actually tell it to regenerate the timestamp for this video. And please note that it does not have any memory. What I mean is, like, the timestamp generator workflow here has no memory. It's just a bunch of AIs working together to actually generate timestamps for it. The only one that has a memory is the assistant, and it's instructed to always respond with the exact data that's being passed by these 2 workflows here. So I'm gonna go back to the Telegram assistant bot. All right, so we got the second timestamps generated again, and to compare it, I'm just gonna go ahead and take a screenshot and put them side by side. All right, guys, so here we can see how it's actually just consistent with different wording. And again, I'm mind blown by how good this works. So in a realistic scenario, what I would have done is I would have just probably changed this part a bit, because this is also part of the components, right? So I'll be like component 1, component 2, component 3, and component 4, because I'm talking about 4 components here. And apart from that, everything else looks amazing, and I wouldn't just touch it. So now, instead of it taking me 25 minutes like it did in my first video, it's only going to take me 5 minutes. So I'm just really excited to actually use this for this video, and I just can't wait, right? And yeah, that was the first example, which is generating timestamps. Now let's take a look at the second example, and we can go with analyzing specific videos. In this case, you can either share one or more video links, but for simplicity and just for example purposes, I'm just going to share this video link again, and I'm going to tell it to please analyze this video and provide me the title and then summary and include the 4 components that was talked about in the video. All right, so now in this case, it's gonna again send the same intermediary message to us telling us to wait. And right now it's actually analyzing the video for us. Once it's done, it's going to prepare an email and send it to us. The reason it's gonna be sending an email is because of the limitation that Telegram has, where it only allows a limited number of characters, and sometimes in these cases, the summary gets bigger. So I decided to just delegate it or use email in this case. Still waiting. It's been a minute. All right, so we can see that it sent us a message saying that the analysis for the requested video has been completed, and it sent an email to us. Let's check what the email is like. So for this, I'm going to go to my Gmail. All right, guys, so now I'm in the email that it has sent us, and look at this YouTube analysis, video analysis report. I analyzed one video and found matching information in one video. Video title, AI Agents Crash Course, a step-by-step beginner's guide featuring n8n, which is accurate. And then the summary. The video provides a beginner's guide to AI agents, which is absolutely accurate, right? And then the 4 components that we asked it to extract from the video is also exactly correct, which is the LLM, the brain of the agent. This is exactly what I actually said in the video, what I mentioned. Memory, tools, and RAG. On top of that, by the way, it also cited the videos for us, and it's able to do this for bigger number of videos. So imagine if I gave it like 5 video links, it would actually extract the information we want from them and then cite each of the informations with the video it extracted them from. All right, so that was the second example, and now we're going to be looking at the third example, which is to scrape the videos of a YouTube channel. And to do that, we'll have to provide the agent with the channel link or the channel tag and the number of videos we wanted to analyze and extract information from. And for this, I'm actually going to be using one of my favorite channels in the space that I like and enjoy watching, which is Leon. And I'm just going to go over and copy his channel handle and go all the way down in our message and say, please analyze the last 5 videos of the channel, Leon, and say, for each of the video, please provide the title and the summary. I'll just go with a simple extraction or simple analysis. And now it's gonna actually start processing 5 of the videos, and let's wait and see what happens. So we received a message saying that its analysis is done and that it sent us an email. Let's go take a look at the email that it sent us. Let's refresh this. And we can see that we did receive an email, right? And this is the email we got. I analyzed 5 videos and found matching information in 3 videos. Videos 1 and 5 did not yield relevant details as their summaries were incomplete or missing. We'll touch on this in a moment, but let's look at the findings that it returned us with. So here are the findings. How I built an AI storytelling team with human feedback, right? When we look at this video, you can see that this is actually the first video, the latest video he has. And then the second one is Vector Shift makes building AI apps super easy. Again, the same title. And then build AI that actually understands relationships. Also the third last video that he has posted. And here we have the summary of the videos. And also notice that we have citations to these videos. So it's like, okay, look, I found this information from this video, right? How I built an AI storytelling team. Let's click on this video. And you can actually see that it has cited us to the accurate video, the actual video it extracted the information from. And here are the videos in the attachment. Now let's understand why I wasn't able to extract any information from videos 1 and 5. At the moment, there can be 2 reasons. The first one is when we try to extract information that doesn't exist within a transcript, like looking for information regarding AI agents in a video that talks about climate change. Obviously, it won't be able to extract any information. That's one reason. And that's obviously not the reason in our case, since we are just telling it to provide us with summary of these videos, right? So regardless of the video, it should be able to extract information, which brings us to the second reason, which is also the reason why I wasn't able to extract any information from videos 1 and 5, is the fact that they are short. And I've added a manual filter to actually read them out because I felt like they didn't add any value but acted as noise. And to make you understand this better, let's actually take a look at the execution of the workflow. All right, so this is the execution log of the workflow that processed our request. And of course, this was called by the agent. And you can see how we have an entry point here and the parameter saying, please analyze the last 5 videos of the channel Leon, and so on, right? This gets processed and goes through the channel route where it then fetches the 5 last videos of the channel. These 5 videos makes their way all the way to this loop here where they later get individually analyzed. And within this loop, we have this if condition that checks whether or not the video is a short or not. And if it is, the condition here acts as a short circuit for the current iteration and continues with the loop. And we can actually tell how it did that for 2 items here, right? Where it break through the iteration, continue with the next item in the collection. And then we can also tell how it was able to analyze the remaining 3 videos, and this is why we got what we had in the email where it says able to analyze 3 videos, but videos 1 and 5 did not yield relevant details, right? And I'm aware that this is not the ideal outcome, right? It should be like, if I want to analyze the last 5 videos, it should analyze the last 5 non-short videos then. Like, why are you just removing the 2 videos? The reason I got to this point for now, I'm definitely going to be fixing this soon, but the reason I initially got to this point is because YouTube does not have a great way to filter data. There are apparently 3 types of data in YouTube, right? They are categorized as short videos, medium form videos, and long form videos. And if I want to filter them, I can only pick one type, but I am interested in both medium form and long form videos. And I wasn't able to filter the query telling YouTube's API to return to me only medium and long form video. And unfortunately, I had to return all the videos and manually weed them out or filter them out myself, which is, I understand, not ideal. And like I said, definitely something I'm going to be fixing. And once I do, I'm going to upload the newer version to my Skool community again. So definitely join the community if you haven't yet. Yeah. But apart from that, you can see how it actually was able to extract the information exactly the way we told it to, right? We told it to give us the title and the summary of the video. And it also additionally provided us with a link to the video as citation. And with that, this was example 3. Now let's get to the 4th example. All right, so we just looked at the examples for the 3 functionalities that our agent has. Now we're going to be looking into the final one, which I think is also the coolest one, just because this time we don't even have to provide it any kind of links to videos or a channel, but just tell it the topic we want it to research for us and then extract the relevant information that we want from them. And then the workflow is actually going to work semi-autonomously by strategically creating multiple queries from the query that we pass to it, and then search YouTube with that and decide on which ones are the most relevant videos to analyze based on the relevance of the title to our query. So without further ado, let's actually get started and test this baby out. So for this, I'm going to tell it to please find me 5 business applications of AI agents, and then provide me a title and then summary and the implementation step by step. And let's send this off and see what happens. All right, so now it's saying that it analyzed the videos and sent me an email. So let's check it out. I'm gonna refresh. And here we can see that it actually did send us an email. So let's check out what exactly it did. So here it provided us with 5 business applications it could find regarding AI agents. And here are the summaries. This is the title. This is the summary, right? These are the implementation steps. And this is the reference to the video as the citation. And then we have tear sheet agent. Not even sure what this is, but yeah, it's built for marketing agency. Apparently, this agent automates the creation of tear sheets by replacing ads on a website screenshots with provided ad creatives and compiling them into PowerPoint presentation. Interesting. And here are the implementation steps for this. Upload the ad creatives to the agent. Specify the websites where the ads should be previewed. The agent scrapes the specified websites, uses AI for object detection, YOLO model, replaces the ads, and generates a downloadable presentation. So with this, the next time I want to actually learn about something interesting, I can just reach out to my agent and tell it to do the research for me, at least the initial research, and then I'm going to look through it, and anything that interests me, I can just watch the video that talks about it. For instance, in this case, we just told it to return 5 use cases, right? But I could have also told it to return 30 use cases, 20 use cases, and it would have done just that. And I would have looked through all of the use cases and pick the ones that interest me and I could dive deeper into those, which is anyway one of the big reasons why I decided to create this agent anyway, along with the timestamps generation. But yeah, that's pretty much it. These are the 4 things the agent is able to do. So without further ado, let's actually get into how I built this, and let's go through the workflow one by one, and I'll tell you what each of the nodes does. But before that, I actually want to try one more thing, because previously when I tried this, it actually worked. And I want to see if it's actually going to work again, which is interesting. So I'm going to tell it to please look for videos on crash course of AI agents in n8n, okay? And find me the video that talks about the 4 components of AI agents. I actually tried doing this today and it worked, and I'm not sure if it's gonna do. So my goal is basically tell it to look for this video. Obviously, I'm giving it all the keywords it needs, right? AI agents, crash course, and n8n. My hope is that it actually finds this video through its search. So let's see what happens. So it starts processing it, and let's see if it actually finds it. If it does again, I'm gonna be really happy. All right, so we just received an email regarding our request. Let's see if it's actually able to find what we are looking for. Let's refresh this. Okay, and look at this, bro. Crash course on AI agents in n8n. Request information on videos discussing the 4 components of AI agent has been compiled now. And look at that. 4 components of AI agents, core components such as the large language model, LLM, memory tools, and RAG, with a focus on Pinecone usage as vector provider. It's just beautiful, honestly. What's this? Tools or automation actions within text or node mean. So I have no idea what this is, but I'm really happy that it was actually able to get the video we are looking for, which is my video, and actually extract out the 4 components we were looking for. Okay, just to prove you guys, I'm actually also going to show the execution log of this request in a bit, so stay tuned for that. So without further ado, let's get to it. All right, so as promised, before I walk you through how each of the workflows work, I want to first show you the execution log for our request. So look what happens here. The agent sends in this request to it: search for videos on crash course of AI agents in n8n and find a video that discusses the 4 components of AI agents, right? This gets to this guy here. This guy decides that this is a YouTube search based task. And what this does is it decides on the number of videos. In this case, it's like YOLO. You know what? Let's search for 50 videos, okay? Since we didn't specify any number to it, what it did was it went in after that to the search query paraphraser that, like I said, generated 7. It's, by the way, it's fixed. I told it to just generate 7. Oh, this could also be dynamic, by the way. I might think about it soon, but in this case, look, it generated 7 queries like this: crash course on AI agents in n8n, introduction to AI agents in n8n. With these queries, it searched one by one on YouTube, okay? And the result it gets, it passes it to IDs by relevance, which is the AI that's actually going to only pick the relevant videos. In this case, it picked 10, and one of this is our video, okay, my video. And then this ID is then passed to this guy here, and what happens finally is it goes through all of this, and let's see what happens. All right, so we can see again 2 of them were shorts and the rest were analyzed, and finally we got a summary list. So this is the summaries that the final agent gets, right? The final AI gets. You can see how it says video 1, the video discusses and then this is the information for that. Then video 2 with this information. Then there's video 3. Video 4 is undefined, where it got short-circuited. Video 5, video 6, video 7, and then we're gonna at least see one more. You can see how there are these being undefined, right? And from all of this, this agent decided that the video that matches ours is actually the one that I was exactly looking for, just because we were talking about the 4 components. All right, now that we have looked at examples of all the functionalities our agent has, we are going to start looking and going through each of these workflow one by one to see how they work. And I'm going to just start with the assistant agent first, since this is the entry point and this is our orchestrator. I'm just going to remove this sticky note behind it for it to be easier for us. And there we go. Let me just pull this one up. Oops, let me bring it back. Hey, buddy, come back. All right, let me grab it. Okay. All right, so this is our agent. As you can see, we have the Telegram trigger as the entry point, right? When we click on this, we can see that it's getting triggered on messages, right? When we send it a message, it's going to get triggered. That is followed by a switch node. This switch node figures out whether or not the message that we send to it is an audio file or just a normal text message. In our case, I forgot to actually show you the use case where we could just send it audio messages. And if we did, in that case, it was actually going to take this path here and then download the file, transcribe it into text, only then forward it to our orchestrator, right? However, in our case, we only use this text message. And what we did here was simply just take the text message that we send it and then forward it to the agent, right? And our agent here has access to a bunch of tools. These tools are generate video timestamps, scrape relevant data, a Gmail tool, and then send Telegram message. So in our first example, when we generated timestamps, this is the tool that the agent used, which is another workflow that we have built. This one to be exact right here. And then for the other three examples, it used this tool right here, which is also another gigantic workflow right here. So the other two tools here we have is the Gmail tool. The Gmail tool is what it used to send us the emails, and then a Telegram message tool here to send intermediary messages, such as, you know, when it said, please wait. Then we have a memory attached to the agent. In this case, you're giving it a context window length of 5. And of course, a model, the brain of the agent. And I set it to be GPT-4o 2024-11-20. And then we have these two output nodes, which the agent uses to send a final response. In cases when it's successful, it's obviously going to be using this node. And in this node, we are taking the output that's forwarded by the agent. And in the error message or the error node, I just simply said something went wrong. Please check the workflow for more details so that the user can, or in this case, I can just come check the workflow for what's gone wrong. And now let's take a look at the prompt of the agent, which is literally the most important part of these systems, because you can have the best structure and the best models, but if you're not able to provide it with the right context, with the right instructions, then you are just going to have a terrible system, at least in the current state of the technology. But yeah, so here you can see that I've broken it down for it into multiple sections. The context section, your role section, instruction section, and then example sections, right? Let me actually put a hashtag here like that. So for the context section, the reason I like to include this is because it allows the agent to understand the part that it plays in a larger system. This way it has a higher chance of behaving in the way that we want it to, just because it understands the context. And you can see that we're telling it that it's a part of a Telegram-based chatbot system for scraping YouTube data and analyzing them. User can request data in 4 ways, and these are the 4 ways we talked about when I was showing the examples. Then we tell it its role, and after that we also give it instructions explaining to it what it's supposed to do in different cases, right? And continuation of those instructions. And now for the case where we wanted to generate timestamps, and then we provided examples so that it can understand how it should behave in different scenarios. So like, for example, we can see here scraping requests with clear intent, without a clear intent, how you should behave in those cases, and so on. Here you can also see that I actually provided it with the current date, just in case if it needs it. So that's pretty much the prompt of this agent. So again, I'm going to be uploading this whole thing to my Skool community, so you can download it from there and also get access to this prompt here. But that's pretty much it for the agent, right? The agent is going to decide based on these scenarios which tools to call and decide on the right actions to take. All right, but I also want to show you how to actually create a Telegram chatbot, just in case you don't know how to do it. But for that, it's really simple. You can just go to any of these nodes and then click on the docs that's being shown here. And once you click on that, you can see that it's actually going to walk you through how to do it step by step, right? You can see refer to Telegram credentials for guidance on setting up authentication. Let's just do that exactly. And then you can use these credentials to authenticate the following nodes: Telegram trigger. All right, create a Telegram account. Obviously you need a Telegram account. Once you do that, what you'll have to do is just start a chat with the bot fodder. I'm going to do that so I can show it to you, right? And then I'm going to open Telegram desktop. Once I do that, the only thing I'll have to do is look at this. I just have to, let me just show you what it says in the documentation. So it says enter the new bot command to create a new bot. And the bot fodder will ask you for a name and username for your new bot, the name, the username, right? Let's do just that now. So let's see. I'm going to say new bot. All right, a new bot. How are we going to call it? Please, oh, sorry. Please choose a name for your bot. I'm going to call test bot. Okay. Good. Now let's choose a username for your bot. It must end with bot. Test bot. Oh, it's already taken. So I'm going to try another test 1239898 bot just in case. All right. Now you can see that it created a bot for us, and you will find it at this place here. I'm going to go there, click on it, and I want to start the conversation. You can see we already started a conversation with it. Now, how do we connect this to the node we have on n8n? To do that, we just need to go back to the message the bot father sent us, and it says use this token to access the HTTP API, right? So I'm just going to copy this, and wherever I'm using this guy, what I'm just going to have to do is I need to click on create new credentials, and the API key that we got from here, I'm just gonna have to paste it here, and then we're done, right? So that's the only thing that we'll have to do, and we'll basically have it set. And from there on, you'll just have to do the simple stuff like, you know, setting up the type of message you want to send and the nodes that you want to connect them to. So yeah, this is pretty much what the agent is. We're also going to be looking at executions in a bit, but for now, let's look into the workflows. We're going to start with the generate video timestamp, since it's the first example that we looked at. And then we're going to be looking at the bigger workflow here for the other 3 examples. All right, so this is our timestamp generator workflow. We start with an entry point using a, what was this called exactly? Wait, let me see what this was called. Real quick workflow, right? Execute sub workflow node. This is what actually allows us to call, wait 1 second. Yes, this is what allows us to actually call this workflow from another workflow, right? And when we do that, now we have an entry point for this workflow that the agent uses to pass in the query and the video link. Of course, the query is optional. The user could have additional query on the generated timestamps. They could say like, oh, make sure the names for these is in a specific format. But apart from that, we have an information extractor that follows the entry point. This extracts the ID from the YouTube video link that is contained in the query. So as you can see, we have this attribute here called ID string, and I extract the YouTube video from the query text here. And then we have a HTTP request node called fetch transcript, which is what we use to actually fetch these transcripts using a website called Rapid API. What we do is we pass in to this API the ID of the video we want the transcripts for, and it returns to us just that. This is, by the way, completely free, so it makes it even more awesome. For this, we'll have to go to the Rapid API's website. All right, so you'll have to head on to this website and then create an account for free, which is really easy to do. And once you're done doing that, you can see the search API search bar here. And when you go there, you can search for this term. Sorry, I just canceled the subscription so I could show you how to subscribe to it. So wait, let's see, GPT, what was it called? YouTube Summarizer. GPT AI, exactly this one. Anyways, I'll be adding these links to my video description, so you can just go there and get to this page directly. But yeah, once you get to this page, what we'll have to do is we'll have to click on subscribe to test, right? And I'm going to do just that. You can see it has basic plan here, and I'm going to click on start free plan, subscribe to it, again, just for free. You don't even need to enter your credit card details or anything. So now I clicked on get started. Once we do that, it's going to give us this Rapid API key, and this is one of the things that we need to make requests to this API, right? Along that, we need this Rapid API key, a Rapid API host, and then just these 3 headers. And I'll show you how to actually implement this. Again, you can just get it directly from my Skool community. But apart from that, so I just copied the URL here and pasted to the field here and took this video ID from this information extractor to the left, right? Apart from that, we'll also have to create headers to be able to send these API keys and the other fields here. So what I did is I took these ones here and then pasted it into this header section as JSON. And that's pretty much it. It's completely free and it works really good. The next node is basically the prompt paraphraser node. What it does is it just takes the user's query and then paraphrases it if the user has additional query apart from just the video link, right? So it could be like, please generate timestamps for this video, and then the additional request, whatever it is, it's going to be paraphrasing that. It's not going to include the link. Like you can see here, it says remove extraneous details such as URLs, identifiers, and specific numbers unless they're critical to the meaning. So that's pretty much what this does. And this is later going to be passed to the refiner, because it's only going to work at the generated timestamps level, and I'll explain to you what that means in a moment. But yes, then we have this transcript node, which is a set node, and what it does is it basically goes to this fetch transcripts node again, and then takes in the data, maps it in a format that's going to be given to the next summarization chain node here, which is going to be generating the timestamp. So we are, by the way, going to be looking at the execution of this soon. Right now, it may not make much sense, but once we actually look at the executions, it's going to start making more sense. So bear with me. So we got the transcript now, right, ready, and then we pass it to a summarization chain. This is a special node where you can actually create summarizations out of large amount of data by using what's called a chunking strategy. And it works perfectly for this use case just because a video can have so much text that it wouldn't be efficient in identifying the timestamps otherwise. So think of it this way, right? A video has 10,000 words. Using these chunking strategies, in my case, what I have here is a recursive character text splitter that breaks the whole video into a chunk of 7,500 characters per chunk so that the agent will be able to work more efficiently. So in the summarization methods and prompts, I picked MapReduce because it's recommended and I think it makes sense as well. Here we have the individual summary prompt, and then we have final prompt to combine. The differences here is that, like I said, because we are processing it in chunks, each of the chunks is going to be analyzed separately. So this is exactly what the prompt is for. So for every separate analysis of 7,500 characters of data, I'm using this summary prompt. You can see here, you are provided with a transcript excerpt from a video. So not the whole transcript, but just a part of it, right? And then the one here is the final prompt to combine. What this does is it takes the whole generated data and then combines it together. And what I told it here is just to combine the following individual timestamp summaries into a final list without further summarizing or altering them. Okay, output exactly what has been generated, preserving the content and order, then align it in ascending order based on the timestamps. And for the individual summaries, I explained to it what it's supposed to do. See, again, context, your role, instructions, right? And very important to use the correct start time value of the correct text that marks the beginning of a major or notable section. So again, to explain this, now imagine we have 20,000 words worth of transcript, okay? And let's say 7,500 characters is just 1,000 word or 1,000 words, okay? This means that to analyze the whole video, the transcript of the whole video, which is 20,000 words, it's going to create 20 chunks, 1,000 words for each, 20 chunks. And that means that we are going to have 20 individual summaries, right? Each analyzing 1,000 words of the video transcript. So we are going to be running this 20 times. And then finally, this guy here is going to take all of it and combine it for us. So that's why we have an individual summary prompt and a final prompt to combine, which is basically what we're doing. And by the way, you may have noticed that I'm not using OpenAI, but actually using Google's Gemini because I find it really actually powerful in this use case. It's really good in analyzing large amount of data and pinpointing the exact timestamp. For this, you'll have to create a Google account, obviously a Google Cloud account. And let's actually take a look at that real quick. So for this, you'll have to go to Google Cloud. I'll just add the link under my video's description. So you can just go ahead and go directly from there. If you haven't created an account already, you'll have to create an account, and then it's going to prompt you to create your first project, right? Once you have your project ready, what you'll have to do then is go to the next page. Go to the next website called aistudio.google.com. Okay, again, I'm going to add this link as well. And when you get here, you'll have to click on create API key. And when you do that, you have to pick the project that you created in your Google Cloud account. And in my case, it's my first project. So that's what I'm going to be referencing. So I'm going to click on that. Once I do this, I can just simply click on create API key. And once you do that, you'll just have to copy the key it generates and just go ahead and click on create a new credential after picking the model, obviously, and click on paste the API key that you have, and you're good to go, right? And that's pretty much it for the Google Gemini part. All right, now we have everything ready. The only thing we'll have to do at this point as a final step is to refine the generated timestamps, right? And that's what this refiner is going to be doing. So let's take a look at what it actually does. We can see that it has, again, the context, its role and instructions. And then I even passed it a sample format in this case. And user query to keep in mind, this is, like I said, where the additional query that's sent by the user is taken into account. For instance, I could say something regarding timestamps, like in our case previously where we had the 4 components, right? I could have told it to have named them consistently. So I could say like component 1, component 2, and this is what this would have worked for. And then you can see the provided timestamps, which obviously comes from the summarization chain that we just executed, right? And yeah, apart from that, we're telling it you are provided with a list of timestamps generated by the first LLM. These timestamps follow a specific format that captures the major sections of a video along with brief descriptive titles, right? Your task is to refine this list by removing duplicate timestamps if there are any, and fixing any formatting issues, right? For example, the generated timestamps here, because of how it's received from the API, it has its format is like this. So it has 3 sections. So I'm using this guy to actually fix that format for us and turn it to the format we can see here. And we actually mentioned that here, as you can see. So that's pretty much what this LLM is responsible for. And with that, we have our timestamp generator explained. And let's take a look at an execution. All right. Here you can see the latest execution that I have. And let's look at the entry point. In this case, it's just the video link. Okay. We get that and we extract the ID from it. And as you can see, this is how the ID information extractor works. It goes in, takes in this query, and it extracts the ID from this link. Even if this query had like extra details, like what the user wants additionally, it would just extract the ID from it like this. Once it extracts it, it passes it to the fetch transcript node with the ID, right? So wait, it's frozen, waiting for it to work. Interesting. All right, yes. So we can see what we did here. We passed in the ID. We took it from the previous node, from the information extractor. We queried this URL with these following headers here. And then you can see the output, which is in JSON. It looks like this. And that is what we are going to be actually mapping with this node here later. You can see how we turn that data into that messy data into a nice string that contains everything together. And if you notice, what I did here was, for each of these timestamps, or for each of these timestamps and the text, I grouped it into this thing inside these parentheses. So start and then the message, right? So that it could be easier for the agent probably to pinpoint the right start time. But before that, we have a prompt paraphraser. Let's see what it did in this case, since we passed it just the ID. Analyze, we're starting at 4 minutes and 21 seconds. Okay, that's really funny. This is not supposed to happen, but yeah, I know why this happened here, because we passed in a link with this parameter here that says 261 seconds. So what this does is it's pointing to the 261 second of the video, which corresponds to 4 minutes and 21 seconds. So because this guy tried to paraphrase whatever it got, it inferred this out of the link, which is not what's supposed to happen, but it's a minor detail and easy to be fixed, and definitely something I'm going to fix before I upload the JSON into the Skool community. All right, then we get the transcript. We map it to the one we just saw just now. The whole transcript is mapped into this. Okay, let's actually check how many words this transcript contains. Or so I just checked the number of words and characters that's inside this text, this whole transcript here. And it says 100,000 characters and 18,500 words, guys. So that makes it clear why we need these summarization chains and why the strategy works really well. If I were just to paste in all 18,000 words, it's not going to work. I've actually tested out. It hallucinates in those cases. So doing this is ideal for these kind of scenarios. And yeah, that's pretty much what it does. So we go into the summarization chain, right? We pass in the whole transcript. It goes in this case, we have 18,000 words. So it's probably going to turn around 20 times or 15 times, whatever, right? And then it's going to go into this individual summary 15 times, summarize it based on the whatever data is given to it. And finally, it's going to run this final prompt to combine. And that's what it did exactly here. To the right, we can see we have this whole timestamps for us, generated for us, which is then passed to the refiner. So this is what the refiner sees here. Provided timestamps and the user query, which obviously is not what's intended by us, but yeah, we'll fix this. Anyway, it worked amazingly at the end. So let's look at the outcome of it. All right, this is the outcome that we got in the Telegram message as the timestamps for the video. All right, so this is how the timestamp generated workflow works. And with this out of the way, we can start looking into scrape relevant data workflow and see how that one works. And as you can see, it's a pretty huge workflow. So let's get to it. All right, so this was the workflow that our agent used for all the other three functionalities that we saw the examples of. And before walking you through this whole workflow, I'd like you to first understand how it's composed so that it's going to be easier for me to explain it to you. It first starts with the workflow being split into three paths, but by the middle of it, it all ends up in the same one. So what I'm going to do is I'll just have to explain to you this part once, since each of these paths is going to end up going through this anyway. So again, I'll just explain this once instead of having to explain it every time we go through these separate scenarios. All right, now that we got that out of the way, I'm going to start walking you through this workflow. And I want to follow the same order we followed when I was showing you the example, where we started with first giving it a specific video link. And for that, we're going to start again from the entry point, right? And in this entry point, imagine the query is a user telling the agent to analyze a given video link. By the way, like I said, that could be more than one video links, right? But in this case, let's say it's just one video link, and tell him to summarize the video, okay? This query router is going to receive that query from the entry point and is going to check. And based on this, as its name suggests, it's going to act as a router, and it's going to direct the workflow depending on what the user has requested. So let's take a look at the categories. We have using channel link or channel handle. We have using video links, and we have search YouTube, okay? In our case, the user is telling the agent to analyze the YouTube video link that they have provided it with, right? So in our case, this agent, this router is gonna direct the workflow into this path. If the user instead passed in a channel handle or a channel link, this router was gonna direct the workflow through this path. Or on the other hand, if the user didn't pass in any kind of channel handles or video links and told it to actually search YouTube and find the user particular information, the router was going to direct the workflow through this path here. But in our case, again, this is the path we are directed to. And the next node here is the video ID extractor. Let's take a look at what it does. Here you can see that we are taking in the query from the entry point, right? And when we do that, what's happening is, so now we got the user's query, okay? And we got the attributes called ID, string, array of YouTube video IDs from the provided links, okay? And what we're telling this is we are basically extracting information from unstructured data. This is what exactly we're doing here. You can see that we are saying extract YouTube video IDs from the given input. The input consists of one to many YouTube video links, and only the video IDs should be returned as an array. And ensure the IDs are correctly extracted from each of the links and separated by commas. There should be at least one ID present, okay? And this is exactly what we are doing. And once we do that, we receive a list of ID and string. And with this set node, we are taking those IDs and mapping it into an array. That's basically what we're doing. And by the time we reach here, we are only taking the same IDs that we got from this and just again turning it into another list of arrays. The reason I'm doing this is because of the fact that each of these different paths has different ways of accumulating these data. So I had to create a common way or common interface that this IDs can just refer to in this case, so that it can just be sure that the IDs it's looking for is always in JSON.IDs. Exactly what we did here. You can see IDs, and then in this case we have the code node, right? Again, we are returning IDs, and that's how we make it work, by having, even when we have different path that leads up to this one here. All right, once you get this, now we have an individual query paraphraser. Let's take a look at what this guy does, okay? So we have the system prompt again, and it takes in the query from the entry point. From here, it's referencing this node. As you can see, look at you can understand from the selector here, we are saying entry point. Please return to me the entry point node and select the first item and .json and the query. This ultimately points to the user query, okay? We have a system message here, and we're telling it its task, and we're giving it examples, another example. And let me explain to you shortly what this does. Your task is to paraphrase the user's full query so that its core intent is expressed and clearly and unambiguously. Remove extraneous details such as URLs, handles, and identifiers. If the query refers to multiple videos or a channel's content, rephrase it to refer to only an individual video. What this means is explained here in the examples that I created with ChatGPT. Here, if the query is, please scrape the last 5 videos of the following channel, right? And tell me what kind of real world problems he used agents to solve, The paraphrase output should be analyze this video and tell me what kind of real problems are solved by the person in the video using agents. And always, of course, I'm telling you to always append it with, if the transcript does not contain the requested information, please clearly specify that no relevant information is available for all the cases, right? So the idea here is, the reason we call it individual query paraphraser is we are changing the context of the query to sound like it's talking about a particular video and not the whole thing. Because what we are doing in this node is we are individually summarizing the video, right? We are not summarizing the whole video. And because of that, what this agent or this LLM gets, this AI gets, is just that video. So it wouldn't make sense if I gave a transcript for just a video and tell it to analyze 10 videos. So that's pretty much what this is doing. And it's a very important part of this whole process. Definitely necessary to have this. And then we have this code node called IDs array. And what it does is, it turns this IDs item here, which is only an object with a single IDs array field, into a direct collection of items. And we actually need this because we want to run it in a loop. So let's say we get 5 video links, or at the end we have 5 video IDs. If I didn't use this and I use this, what's going to happen is this loop is just going to get this one single IDs field here and just run once. So what I'm trying to fix here is, what I'm trying to do here is, I'm trying to return to it instead a collection of items directly. That's what I'm pretty much doing here. In our scenario, since we just have one video, this is gonna only have a single video, right? Now we are entering into a loop. Inside this loop, what we have is the collection of arrays, but passed in as a single item. And again, we just have one ID here, so we're just only gonna iterate through this loop once, and that's it. But let's understand what happens inside the loop. So we go into the loop and we have another HTTP request node called fetch video transcript. And inside this, we have the same rapid API implementation that we had previously in the timestamp generator workflow. The same thing, what we did there, we are doing here, but this time we are returning the transcript for a different reason. And then we are seeing the same thing here that we saw previously when I showed why we were not getting the information for all the videos, is this if conditional check to see whether or not the video is a short or not. If it is, what it does is it short circuits from the iteration, continues with the loop with the next item if there are any more left. But in our case, it's not a short, it is my video, which is 15 minutes long, so definitely a pass. It passes to the next map transcript node. Again, we are mapping the transcript, but this time along with its title. In our previous, in the other workflow, remember, we were only mapping it for the transcript, and this time it's different. So that's what we are doing here. Also, we are mapping it in a different way. Since we don't need the timestamp here, we're just getting the text of the transcript. Once we get the transcript, this is then passed to the individual summary again, and we are using the Gemini chat model for this summary. Oh, by the way, I forgot to mention, for this we are using 4.0, and for the summarization I am using Gemini. Again, it does really great with huge context, and in this case I'm not using a summarization chain, but I'm just throwing everything to it. Since we don't really need to know the timestamps, it's going to be a much easier job for it to work with, right? And now let's take a look at the prompt. You can see again, we have context, we have the role, and then we have important, we have user's query, right, to take into account the user's query. And obviously we need this because we want to extract the information that the user wants and not just general summarization of the whole transcript. So this is the transcript section, starting with a title and then the whole transcript in general. What we are telling this LLM to do is that it's provided with a video transcript and a query that specifies exactly what information the user wants extracted from the transcript. The transcript may contain numerous details, and your task is to carefully review it and extract all relevant information that addresses the query. Ensure that you capture every pertinent detail so that the final output completely fulfills the user's request, right? And then we explain its role. You are an extraction agent whose objective is to analyze the provided video transcript and extract every piece of information necessary to answer the user's query. Your response must include all the details requested without omitting any important information. Present your findings in a clear and structured manner. Again, I'm not going to go through the whole thing, but this is basically what it's telling the agent, that it should extract the relevant information the user is looking for, right? Once we are done with this part, The agent summarizes it and then passes it to the summarizing field. What we do with the summary field is we take the text. The text is the output from the individual summary, and then we pass in also the link. So we take in the link, and that is what we end this whole loop with, right? And then by the end of it, we're gonna have a list of summaries, and within this list, we are gonna have this information here mapped in the following way. So we'll have the video number. Okay, for each video, we're gonna add the index, and basically for video 1, it's gonna say video 1, video 2, video 3, and so on. Then we add the link, and then below it, what we add is a transcript without any kind of label because it's obvious, right? So that's what we return from this summary list, which is then going to be used by this collective summary LLM here. But before that, we get to this collective query paraphraser, and let's take a look at what this does. But let's remember how we had an individual query paraphraser, right? The way this is different is, let's take a look at what it does. It's pretty much the same thing, but in this case, let's look at the example. So if the user said, please scrape the last 5 videos of the following channel, and tell me what kind of real world problems he uses agents to solve, the paraphrase output is going to be analyze these video summaries and provide information on the real world problems addressed using AI agents. It pretty much does the same thing, just in a different context, right? In that case, we say analyze this video. In this one, we say analyze these videos. So from singular, we got to plural. And yeah, that's pretty much it. And once we have our query paraphrase, we are going to be finally summarizing it collectively, as the name again suggests here. The difference is this is an individual summary. This one summarizes the whole summary, right? It doesn't really summarize it, but it collates or brings together all the information that has been gathered. Let's take a look at the prompt. All right, so here we start with the context section again. We are telling it that it's being provided with summaries of multiple videos and the amount of video that is going to be given, right? Or it's given, and its task is to analyze these summaries along with the user's query and extract what the query is looking for. If a summary does not contain any matching information, simply ignore it, okay? And then we pass in the user's query, and we talk about the analysis here. Review all the provided summaries from the number of video transcripts, right? And begin your response with a sentence summarizing the overall analysis in the following format. All right. And list the key finding as numbered bullet points. Content requirements. Make sure to not omit any information, which is really important, right? We don't want it to summarize the summaries, but actually, again, bring them together in a presentation format. But apart from that, output example format, I analyzed X videos and found matching information in Y videos, exactly what we saw in the case where we were able to extract from 3 videos and not from the other 2. And here we just talk about the format of response it should provide us with. And finally, the content, where we have the user query and video count and also the summaries. And of course, we are also telling it to include the video links as the transcripts here, right? And this is why we are actually extracting it here, so that we can use them as the transcript to the information it has extracted for us. All right, now that we saw an overview of how this workflow works for this use case here, I'm actually going to be showing you the execution log of the example I showed you previously, so that we can actually see it in action and what really happened when we send the request in the example. But again, I'm only going to be showing the whole workflow once. And for these other 2 scenarios later, I'm going to show all the way up till this point and leave this part to your imagination, since you will already know what happens here, right? So without further ado, let's get to it. All right, so this execution log here is for this request that we made, right? And you can see how it said processing your request, please wait, and then responded to us telling that it sent us an email. Of course, this workflow was called by our agent. So let's actually take a look at what happened in the agent as well. Then we will come back to this workflow and finish up this whole thing and understand what happens. All right, so this is the agent part of the same execution log. And here we can see that we get a message from the Telegram trigger saying the exact same thing that we said here. Please analyze this video, right? And this goes to this switch router here. This based on the type of message, since it's a text message, it's directing the workflow through this path, which is the message text, and then it gets forwarded to the agent. Once it gets forwarded to the agent, I'll tell you roughly what happens. It basically processes the query, right? And then it adds it to the memory, and then it decides on what it wants to do. After deciding on calling scrape relevant data tool here, it first sends us this intermediary message That's this processing your request. Please wait. And then later it calls scrape relevant data again, right? Actually, sorry. It processes the model again. The model decides on what it should do next. It comes and it decides to call scrape relevant data. The scrape relevant data returns this response. Okay, it sends a, by the way, this is the query or the parameter it calls it with, which is our request, our message. And after this tool returns the response, it again processes it within this LLM. This LLM, okay, is like, okay, we got the response now. Now it's time to generate an email. So it sends an email this time. And then it sends an email. And when it's done sending an email, it finally returns an output as a response saying, hey, the analysis for the requested video has been completed. The title, summary, and the 4 components discussed in the video have been sent to your email, right? Now that we understand what happened in the assistant agent, let's actually take a look at our workflow now and see how it processed the request. So here the entry point is the query that the agent called this workflow with, right? Is the same thing here. And then once we get this response, you can see we go into the query router, and the query router decided that, okay, this query here contains a video link, so I'm just gonna direct the workflow from this through this path. And then this video ID extractor checks this query, is like, all right, so this is what the ID extractor sees, the whole query, and it's like, okay, so the ID I want to extract, or the IDs that I'm looking for, is this. It extracts it. Then we map it here with this set node. Remember, we were trying to create a common interface that this node here can refer from to map the IDs. So then we get to this again, this guy maps the IDs. And now we pass the query to the individual query paraphraser. Let's take a look at what it came up with, right? This is the query it gets. So HTTPS, blah, 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 the link, and our message here. It took this, and according to that, it generated this paraphrased version of our query, right? Analyze this video and provide the title, a summary, and details about the 4 components discussed in it. If the transcript does not contain the requested information, please clearly specify that no relevant information is available. Boom, we got this ready now. And then we get to the point where, like I said, we are just mapping the IDs array in a code node to be able to use this loop here. We get that this is now what we have. We are returning a direct array of items or collection of items, right? And this goes into the loop. Now the loop has only one item, so it's gonna start processing it, and it goes to fetch transcript. The fetch transcript takes in the ID of the video, outputs the transcript, and then we have this condition that checks whether or not the video is a short form video or not. And here you can see that it is greater than 180 seconds, and this is the duration here. Okay, so that is why it passes it and allows it to continue through the iteration. Then we map the transcript, and this is the map transcript that we get along with the title, by the way, right? The title and then the transcript here with all of these details. This time we didn't need the timestamps, but we just got all of it together and turned it into one huge text, which is then passed into the individual summary. The individual summary reads it and processes it according to our prompt and comes up with this output here: title, AI agents crash course, and everything. And it explains, of course, it reads that we want to find out about the 4 components. It comes up with that saying LLM, see, memory, and all of that information that's relevant to our query. It gets that, and once it's processed and it outputs its result, it gets mapped again using this summary node. The summary node turns it into an object with a field called text, where it puts in all the transcript and another field called link, so that the next LLM will be able to use this as the citation of the extracted information. And with that complete, there is nothing else to process in this loop. So what's going to happen is it's just going to output this data through the loop. And because we only have one item here, we're basically done. And that's what's forwarded to this next node here, which is a summary list code node, as we already talked about it. And what it does is it turns this and maps it into a huge text again, right? And the format here is video and then link, and then the transcript, we can see how it goes with video 1, because there's only one video right now. But if there were 2 videos, the next video was going to start with video 2, and then it provides the link and then the whole transcript underneath. Yeah, then we go to the collective query paraphraser, takes in the query. So again, this is our original query, takes in and turns it into this one here. Analyze these video summaries and provide the title, a summary, and details about the 4 components discussed, right? And then forwards this query to the next node, which is the collective summary LLM. And this time, this guy receives the user query, and which is the paraphrase user query, analyze these video summaries, again, the one that we just paraphrased in the previous node. And then it gets the content, a section where the user query again is passed to it. The video count is mentioned, and below it are the summaries. In this case, we only have one, which is video one, right? And based on that, this agent has come up with this output here. I analyzed one video and found matching information in one video, right? And this is basically it. And this is what we received in our email. Let's take a look at it actually. So this, I analyzed one video and found matching information in one video. And this is basically what has been output to us, which was all prepared by this workflow here. All right, now that we saw this in action and we also covered the first use case, let's start looking into the other two use cases here. And again, I'm just gonna cover all the way up to this part here and just leave this to your imagination, since now you know what happens after we pass through this part of the workflow, right? So without further ado, let's start with the second example, which was when we passed it the name of the channel and the videos we wanted to analyze from it, right? The analysis of 5 videos. See, please analyze the last 5 videos of the channel. For each of the video, please provide the title and the summary. And this was the path that this workflow took in that case. So let's first look at the overview of how this works, and then we'll look at the execution log. All right, so for this example, let's assume that the entry points query is about analyzing the videos of a channel like the one we have here, right? Or we can just say it's the same query. What's going to happen is, again, it's going to go to the query router. The router is going to read the query and say, okay, this guy is asking me to analyze the 5 videos here of this person's channel. So it must be using a channel handle, because I can see a channel handle, right? So because of that, it's going to actually route the whole workflow through this path, and then it's going to get forwarded to this channel scrape data extractor, right? And what it's going to extract from it is the handle of the channel. It could be from a link or directly just the handle, and the number of videos, okay? And the number of videos in this case is 5, right? And the channel handle is Leon Van Zyl. And once it extracts the data, it's gonna forward it to the next node in the workflow. And the next item in the flow is the HTTP request node that's named get channel ID by handle. Here, what we are doing is we are trying to get the ID of a channel using its handle. So we are gonna pass Google API, the channel handle that we got from the extractor here. And then with that, it's going to return to us the ID of the channel. We are going to use the ID returned by this request later to fetch the data that we need from this channel, right? And before that, we'll have to set our credentials, basically the key for this. And we'll have to go back to our Google Cloud Console and generate a key for it, and then attach it to this URL here as I did, like so. But I want to let you know that the key here is really important. Never share it with anybody, because if you do, they can have access to it, and then they can use your key to actually send requests to Google, which would start accumulating as cost to you and not to them. So if I were to like show this key to you and not delete it before I posted this video, you guys could have just used this key and start sending requests using it, right? And I would have to pay for your request. So definitely keep this key as a secret. That's what it's supposed to be used for. And not only this, but any kind of API keys that we saw, right? From Gemini, for OpenAI, for even Telegram, for instance, Rapid API, and all of those, you need to keep these keys as a secret and not show anybody. Usually we don't want to have this kept here in the URL. Here I'm just trying to make you wary of this so that you don't go and share with everybody your keys. But yeah, so let's go to Google Cloud Console and get our key so we can actually use this URL, okay? We'll go there, and once we are here, again, we already created our account, as you remember, when we were walking through the timestamp generator workflow. So once we are here, we're going to go to this left dashboard to the left, and then I'm going to click on hover over APIs and services, then click on library, right? Once we are here, we're going to search for YouTube and click on YouTube API, data API v3, and then click on enable. So we'll actually enable this, and it's going to start allowing our account to use this API. I'm enabling it. All right, now we are being directed to another page. And once we're enabled, like I said, we're directed to this new page here. Within this page, let's go and click on credentials to the left here and create a credential for us by clicking on create credentials. You can see that this is my API key that is generated. This is what you are also going to be getting. So copy this and paste it to the URL that I just showed you just now. But I'm just going to go ahead and delete this so that it doesn't get used by anybody else. And now let's go back to our workflow here, and there we go. We have the key. We'll have to just paste the key here, okay? And now we're going to be able to use this URL to fetch the ID of the channel from the channel handle that we provided with. After we get that, we map the channel info using the set node to an object with a field called channel ID, and that's what we are mapping here. JSON items 01.id equals to the ID of the channel. We'll actually look at this in the execution flow and see how it works and what the data we get as an input and look at the output of it. Then we have this wait node here, and what this does is simply just pauses the workflow for a second. The reason I did that, I'm not sure if it's even necessary, but it's just a habit I've got from programming, is because we are sending a request to Google, right? And then just instantly after that, we are sending in another request to it. I just didn't want to overwhelm it and kind of try to create a balance. But yeah, in this case, just because we are just doing it once, I don't think it's even necessary. But like I said, it's just a habit from my programming practice. But once we're done waiting for a second, we head on to our second HTTP request, where this time we pass it the channel ID that we just extracted from this HTTP request. And then we also pass it the number of videos, which again was extracted by this node here, right here, number of videos. So we got that extracted, and this time we call the Google API again using our key here as well with these two parameters. We are telling it, hey, I want to get the videos from this channel ID, and I want to get this many videos from them, right? Order by date, and the type of video, the type of content I want is video, and that's pretty much it. It's going to return the videos for us. And here we are going to be mapping the IDs once again into this common interface that this node can later understand, right? So they can work with all these three different paths. And once we're done with mapping that, we are going to take all of this data and then push it through the same flow here, which we are not going to cover anymore. And that's pretty much it. So that's how this is different from this example we saw. Here we just passed it the video IDs or ID or IDs, right? This is going to extract it and get the IDs. The only thing we're trying to do at this part of the workflow is get the IDs of the videos, right? So here, the getting IDs is very simple. It's already passed to us via the query, and we get the IDs, we map it, and then pass it to this node here. Here it's a little bit different because we are trying to get the videos from a channel, so we have to pass it the channel name, and we get the channel ID. With that channel ID, we query the channel, and we also use the number of videos as a parameter to tell it how many videos it should return to us. And that's how we receive the video IDs in this scenario, right? And we'll also be looking at how this flow here gets the IDs. But before that, let's actually check the execution log for this based on the example we have here. All right, so this is the execution log that corresponds to the example here. We can see that the entry point has the same query as the one we had here because it's basically that. And in this case, I'm not actually going to show what happens in the assistant or the orchestrator agent, just because it's the exact same thing as it did for this example here. So I'm just going to omit that since the video is going to be really long, right? But we look at what happens in this workflow instead, since this is the only thing that changes in the way it works. So in this entry point, we get the query. This time the query router checks the message and says, okay, this guy tells to analyze the last 5 videos of this channel. So it understands that we want to extract videos of a channel. So it directs the workflow through this path, okay? And then the channel script extractor extracts the handle as we talked, and then the number of videos, right, from this query here. And then this gets passed to the next node, which is the get channel ID by handle HTTP request node here. And you can see how it passes in the handle to it, right? And then it's forwarded to the next node, and this node uses the JSON handle, the handle of the channel, and queries YouTube's API, and from that it returns this response here, which is later used, right? And we're going to look at how it uses soon. And then in the next node, we are mapping it into channel ID, and the way we get it here is you can see how we have JSON, right? The return object, okay? This is what JSON refers to, this object here. And then inside it is the items field. It goes into the items field, and it's like, okay, return to me the first item inside this collection or inside this array, and get me the value of the ID field, and then assign it to this channel ID. And as an output, we have this mapped object here with channel ID and the value. After that, we enter into the wait node, we just wait for a second, right? And now we are finally fetching the videos of this channel. So in this case, this is what we send it as a query, right? We're saying this is the channel ID, max results 5, please return me the videos. And this is the output from this request. So we did get the videos. We can actually say, we can tell from here, results page. This channel apparently has 183 videos, by the way. So we are returning 5 of them. Okay. After that, we forward it to another set node where this time it extracts all the IDs and then maps it into this object with an array called IDs, right? You can see how there are 5 IDs because we requested for 5 videos. And once we have all these IDs, it continues with the rest of the workflow, which you already know what happens. All right, so now we understand how these two scenarios work, right? And the only example that is left is this YouTube search scenario, and we're going to be looking into that now. So let's get right to it. All right, so for the router to decide to follow this path here, the message we sent it was, please find me 5 business applications of AI agents and then provide me a title, summary, and the implementation step by step, right? So let's assume that the query here is exactly the same as well. And let's look at what's going to happen, right? We already know what's up with this query router. It's going to be like, all right, this guy wants us to search YouTube because there is no video link, no channel tag, and the request is about looking for things. And because of that, it's going to route the workflow through this path here. And once we get here, we have this YouTube search extractor. Let's take a look at what it's extracting exactly. All right, so this too extracts the number of videos, but it's more implicit compared to the one that we have in the channel route here, because in this case, it's actually a requirement and we wouldn't be able to pass the validation of the agent if we didn't provide the number of videos we wanted to analyze from the channel. But in this case, the LLM is actually going to intuitively decide on the number of videos it should actually query for based on what the user's query is, right? Let's take a look at this system message here. We can see it says the query refers to YouTube and your task is to extract the number of videos the user wants to analyze, find, or scrape from it. If the user does not explicitly specify the number of YouTube videos, then strategically decided based on the query, maximum number of videos are 50. I think this should be is 50. For instance, if it says, find me 7 use cases for ABC. This talks about 7 use cases, not 7 videos. So the number of videos is up to you. But if it says find and analyze 7 videos on the use case for ABC, then this talks about 7 videos to analyze use cases. So the number of videos is 7 in this case, right? So that's pretty much why we have this extractor here to decide intuitively in the cases where the user does not explicitly mention the number of videos to analyze. All right, so once we get this extracted, we have the search query paraphraser, and this is where we actually create multiple queries out of a single query, right? And this is the prompt. Here we have the context, the role, and then the rules. So the context is you are provided with a user's query that may include instructions to search and analyze a number of videos. Your task is to extract and distill the core search terms that accurately represent the topic of interest. You are encouraged to rephrase the query into natural, engaging search phrases that are optimized for YouTube results, right? And then I tell it to, I think it was 7. Generate 7 distinct search queries that each capture a different angle or nuance of what the user intends to search for. Okay, and this is basically what it does simply. And it generates 7 different queries, and with that we map it into an array of strings. Okay, so we'll, by the end of this, we'll have 7 items, 7 versions of the same query. And those 7 versions is going to be running through this loop here, which is going to run one by one for each of these queries. And what it does is it goes into, again, the YouTube API. And this time it uses this parameter here that says Q is equals to JSON query. And it's going to run this 7 times with the 7 queries that it generated. And for each of them, we are going to just tell it how many videos we want it to return. And again, this is extracted or generated by this node here, right? And here we are using the same ID as we used for when we were looking for the channel ID and the channel's videos, because we are accessing the same Google API. So anyway, once we get the videos, we'll go to this next node here that waits for 2 seconds and repeats this for 7 times. And all of these video gets accumulated by the end of this loop here, which again 7, and depending on the number of videos, it's going to be 7 times whatever number of videos we're looking for, and that's turned into this videos array. We are mapping this into videos array, and we are also making sure here that we are distincting it by the ID so that we don't get the same IDs twice. So simply what we're doing here is just this. We are, let's say we get 100 videos by the end of that process, right? And in these 100 videos, there are 20 videos that occurs more than once. So what we're doing here is we're making sure that the IDs that we get is all unique and one of a kind. Once we get those IDs, what we do is we go into this next node here called IDs by relevance. This is the node that's actually going to be going through all of the video IDs with their titles. I forgot to mention here, we also are returning the ID with its title and actually description here. And based on that, this model is going to decide on which ones are the most relevant and only pick the number of videos that's been extracted from this node here, right? So now let's talk about a scenario where the number of videos were 5, okay? And we know that we generate 7 queries, and we're going to be running this loop 7 times because there are 7 queries. And when we get into the fetch and search video node, we are returning a max result of 5 in this case, right? So this whole process can return up to 7 times 5 videos, which means it can return up to 35 videos, right? And once it goes to this IDs by relevance, this IDs by relevance LLM or node is look at the title and description of all the 35 videos and then compare it to the user's query. And based on the relevance they have to the user's query, it's actually going to extract only the number of videos that's extracted from this node here again. Is going to only extract that many of the videos from those 35 total videos, right? So in this case, it's only going to extract 5 of those videos and get rid of the 30 videos that's less relevant compared to the 5. And once it filters out the IDs, it's going to output it in this following structure here, where it's an object with a field called IDs that holds an array of string, in this case, array of IDs. It's basically the same as this here, right? It's the exact same thing, but we're telling the LLM to do it in this case. And then the output of this node is going to be passed to this code node here, where it's going to turn it into a direct array of items, which then again is passed to this node, and we know what happens after this. So yeah, that's basically the overview of how this search scenario works, which is much more complex compared to these two. But yeah, since we got this overview out of the way, let's actually take a look at the execution log for this, and then we are going to be done with the video. All right, so this is the execution log that corresponds to this final example here, where we told it to find 5 business applications of AI agents, and we can look at it in the entry point here within the query. Please find me 5 business applications of AI agents, and then provide me a title, summary, and the implementation step by step. Let's take a look at what happened. So it went in the query router. The query router decides that it's a search YouTube based task, so it directs the workflow into this path. And here we got the YouTube search extractor. It decided to query for 50 videos, which is pretty crazy, but let's see what happens next. And then it goes into the search query paraphraser, which generates 7 different queries for us. But here, interestingly, it actually decided to do its own thing and only generated 5, which is okay, cool. I respect that. You know, honestly, it might be enough to generate 5. So I think we can call this autonomous, man. What the heck? You're not gonna listen to me now? Come on, man. Like, I specified it to be 7, right? Yeah, I did. So wait, let's see where it is. Yeah, you can see I said 7, but it decided to generate 5. Okay, no problem, respect. And probably what happened is other parts of this prompt here encouraged it to do so. That is why it's also important to continuously test your work until you are sure that it works exactly the way you intended it to, so that you don't come across things that are unexpected like this one. But this is a small problem, so let's just see what happens next. We go into the queries array, we get the queries, right? We turn it into 5 different queries, and for each of it, we're going to be searching YouTube's API or querying YouTube's API with 50 results for each of it. Okay, you can see how we got the AI agents every business needs to skyrocket. We got all these results, and this is one of the 5 queries that we made. So we potentially have 250 videos to actually analyze. And here we got the videos array, we get the IDs and the title and the description, right? And the description is not complete here, but it's enough for it to just infer the relevance. Then this gets passed to the IDs by relevance, and we can see that the IDs by relevance only extracted 5 of the videos to be relevant enough. Interestingly, even though again I told it to do 50, again autonomy, I guess. But yeah, you know, after all, it works great. But definitely something I'm gonna be looking into to fix this. But also 50 videos might be too much anyway, so I think I'm gonna limit it to like 20 videos when we don't explicitly specify the number of videos we want it to analyze for us. Anyway, then it goes into this IDs node, okay? And when it does, again, it maps it to the way we want it, and then goes into the individual query paraphraser, and the rest is history again. So that's basically it. This is how the third example was processed by this part of the workflow here. And with that, we are basically done with this workflow and the video. The video was kind of long, but yeah, I actually had fun, but I'm just really tired. I'm filming this the whole day. But yeah, what an experience, man. Yeah, and also definitely this part here is not working as I intended exactly, even though it works pretty well. Like the outcome is really good, but something I have to work on the prompts again. As I mentioned, it took me more than 40 hours to actually build this, but this was towards the end, so I didn't really put in so much effort to test it. And this is a good lesson for us to understand that we actually do have to test it, right? My next plan is to actually just make sure to limit the videos. 50 might be too much for this, but I want to make sure that once it extracts the videos here, it extracts the amount of videos that we specified to it over here, right? If this says 50, this should have actually extracted 50 videos, which it didn't. And the queries part, I'm actually okay with it. Like 5 can be enough, but I'm gonna also take a look and see what may be making it decide to only generate 5, because I remember at first I set 5 to it. Maybe somewhere there I might have actually left that prompt. Let me see. Yes, okay, yeah, exactly. That's what's happening. Your output should be a valid JSON object with a queries key containing an array of exactly 5 distinct search queries, and then we have 7 distinct search queries. So I just missed out on the one that's here at the bottom, and that's basically why it decided to generate only 5. See, we already solved this problem. The next problem I'm going to be solving is the ones I just mentioned here. But with that, we are done with the video, guys. I hope you found this video helpful, at least to understand at the surface level how things like this can be built. This video has been challenging, but honestly a really fun experience for me. And again, I just hope you enjoyed the video and that this video added value to you. And yet again, I'm going to be uploading this to my Skool community, so definitely join it if you want to get access to it. And by the way, I really can't wait to use the timestamp generator for this video. I want to see what's going to happen, like what the result is going to be. I'm really confident that it's going to do an amazing job. So definitely check out the timestamps of this video as well, because it's going to be 95% done by it. I'm maybe just going to change 1 or 2 titles. That's it. But with all that said, take care, everybody. Have a great day. Bye.